Hi, welcome. I'm trying to learn particle physics. Today with standard model, and after we've done it, we're going to do a bit standing yoga. And if you participate in the standing yoga, but sit down, obviously. Sure enough, the bumps and particle collider data soon began to appear, together with goosebumps on the skin of the theorists. Now, evidence for the three quarks had already been established in experiments. Now, these quarks, there was the unified electroweak theory, to which all particles succumb, and quantum chromodynamics, which affects only quarks and gluons. And these quarks were inside of the protons. And these protons are inside of the atoms. The atoms are held together by the strong nuclear force. Inside of these electrons, inside of the atom, inside of these holds fermions. There's the electroweak force. And the electromagnetism force that goes through all the field, and that is the bond of the photons between the electrons. And then there's the force which is the Higgs boson from one fermion to the next one, but we don't really understand anything of it so far. Evidence for three quarks had already been established in experiments in the late 60s, but by the end of the 70s, physicists in the US had inferred the existence of a fourth and fifth. Finally, in 1905, physicists at the Tevatron Collider in Fermilab in Illinois found the sixth, the top quark, and by 2000 the tau neutrino, the last of the leptons, was discovered. Also at Fermilab. And on the other side of the pond, the gluon was snared at the DSI laboratory outside Hamburg, Germany, 79. Okay, during the 60s, 70s, 90s, 2000s, all these different types of quarks and leptons inside of the fermions, atom, whatever, were found. And it was now not just theory, but they were found. Today, the standard model is complete, with every particle it predicts having been discovered, albeit sometimes decades after the prediction. See diagram above. Okay. The particles of the standard model have been consistently predicted on paper before they turned up in reality. Theoretical progress, experimental verification. I don't really get it now. Okay, just a little overview. Here somehow were some things discovered, and then they're here discovered. I don't think we really have to understand it now. I wanted to go to these two graphs later. They were predicted before they were found. For Weinberg, the standard model's triumphant march has been something quite special. To fool around at your desk with mathematical ideas and then find that, after spending a few $1 billion, experimentalists have confirmed them, there really isn't anything comparable to it. So he says it was quite nice to have these ideas, and that will then turn out to be true. Even so, he and his like are still looking for deeper theories beyond the standard model for all sorts of reasons. Why, for example, do particles come in three generations with, for example, the heaviest quark weighing 70,000 times more than the lightest? Let's think about that, what is meant here. The heaviest quark 75,000 times heavier than the other one. Now we know that the quarks, the more they are pulled apart, the stronger are pulling them together. Thus, the heaviest one is 70,000 times heavier than the lightest one. There are up, charm, top, down, strange, and bottom quark, 6 of them. Yes, why is one of them 70,000 times heavier than another one? Are we all in the same place? Is there a place wherever we are inside of a proton random? Or has the position something to do with it? What if their position has then a difference to the other leptons? Also, is it the same with the leptons that if they pulled apart like the quarks that where strengthness pulling them together changes. If you think about it, it must be something pretty easy. All these other explanations here, but where is the photon shifting the properties of the electrons, that were different types of them, always in pairs. That seems so easy. Whereas the Higgs boson transporting it from one to the other, the photon from one to the other, Higgs boson transporting what was the Higgs boson doing? The Higgs was needed to ensure that during the breakdown of the unified electric force, the W and Z particles acquire mass. It's an atom, and inside of this atom there are the electrons and the atoms and the protons, and the protons inside of them have these quarks. Nowhere no the leptons that didn't really get wet. But I think the answer is pretty simple, basically, again. It's just some unknown type of force which causes it, but it's out of the same physical roots. Or the same pretty standard rule. Maybe the roots are a little different. Maybe it's a fourth type of force, but that is my question, basically. The one which I had just because I brought it up, is the position random? Are they like the solar system that inside of the middle, that the inside these of them acting on each other like that? As you pull them more apart, they're getting more apart. So how close are these quarks inside of each proton? Are they all together? One of them has to be logically in the middle. They are not merged. Now, if one of them is in the middle, why is it now? Basically, the idea is, if you pull them apart, no, the idea is not. The idea is more like the solar system. In the middle of them, the one in the middle is the most heaviest one. And it is in the middle, why? Maybe because in our question have the leptons an influence on the quarks. What if the leptons have also something like that, but they are on different levels, but these levels have influence on each other? I think the answer is quite logically, that's the idea. But it's just one of the quarks, the heaviest one is in the middle. Or it's the lightest one in the middle, that's also an interesting thought. And the other are traveling around it, and they are traveling around it, like circling around it, they're orbiting around the other one. And the faster they orbit, the further they are pressed away from the center one, the lightest one. But the faster they get and the more outside we get, the stronger they are pulled together. So we can't get further away. But something is making them spin faster around each other. But how does it become the heaviest one? Do we have, it was not written if the quarks can change the properties, that would be also interesting. Is it always the same 175? Is it exactly 75? Is it in all atoms always the same number? Or at least all atoms of the same kind, of the same element? So my best guess would be it has something to do with the position where they are, maybe the atoms by influencing each other, or it is something with spinning. The lightest one in the middle would actually my suggestion, not the heaviest one, the lightest one in the middle. And the furthest away one is the spinning the fastest, but there are two. Maybe they are spinning like the super galaxies, which can shoot also these laser beams into both directions along their spiral internal whatever thing. The galaxies maybe they are both circling around it, and they are spinning very, very fast. And now it brings them further apart. But because we're further apart, they are pulled stronger together, and we're keeping that balance, and that keeps the atoms together, and that keeps the time-space continuum, whatever. I'm just picking the next subject up, but maybe it has absolutely nothing to do with it. Whatever, and that keeps it together. And that is why it holds, and that is why an element does not suddenly change to become another element. What if black holes are just another element? What if just a little here? What if it's searching completely wrong with whatever causes a black hole? Not just too much mass of a collapsing super galaxy with too much mass at one point. Yes, maybe too much mass at one point that this heaviest quarks, the atom spinning around the other one, is too much influenced by the next atom. They are merging together, and now these quarks are coming together, and it gets whatever the quarks of two atoms of two protons merging together, and that causes a black hole. What if something like that? Why should the black hole start just with too much mass at one point and not smaller? Why should it basically start at the atom level with too many atoms or too much mass at one point and not with too much quarks at one point? What if suddenly there are two protons merging and there are now 12 quarks in one, and all of a sudden this, which held it together with the outside two quarks spinning with 75,000 times the mass of the light one in the middle. I'm staying with the one in the middle is the light one. What if there's something else enough? Now I'm gonna end with here. All what I just said wasn't anything. I think that's obvious if you followed. These were all just hypotheses. If you were here for particle physics, you can go directly to the next part. And if you stay here, we're going to do standing yoga. If you participate in this, now we're having again just 3-4 minutes. I'm not going to do a second power yoga. If you're here for standing yoga, that's it. If you participate, feet is together and we're doing the eagle swings, breathing in with the arms up. And breathe out the arms down. And in the arms up. And out the arms down. And in the arms up. And out. And in the arms up. And out, lean back for crab in the morning, to shoulder blades together. Again, in up. And out the arms down, draw the shoulder blades together. Again, in and up. Close the hands and lean back, read in the wind. Again, in. And out, lean back. Again, in. And out, leaning to the side, the fire in the wind. Again, in the middle. And out over to the other side. Again, in. And out the arms down. And we're doing standing calico. We're leaning with the hands onto our knees. We're breathing in. And out. We're making a round back. Breathe again in into the middle. And out. A belly with a paper cow. Again in. And put it out back. Again. Out. Breathe in into the middle. So now we're coming up. Making the backward shoulder. Now we're lifting the arms up. And out. Doing it down like a dolphin. Going down. We do a marmot, breathe in and lift the right leg. And breathe out and stretch the left leg. Breathe in and change. And out and stretch the right leg. Again in. Out and stretch the left leg. Get in the middle. And breathe in. And lift the right hand up to the sky. Breathe out, bend the left knee, look up the right shoulder to the right hand. Breathe in, the hand in. Out and down. Breathe again in, lift the left hand up to the sky. Breathe out, bend the right knee and look to the left hand up to the sky. Again in, the hand down. Out and down. Breathe in halfway up into monkey half. And out and down. Again in, halfway up, monkey half. Out and down. Breathing in, come up. Close the hands. And open the hands again, the sky hug up to the sky. Again in, the hands up. Out again, back. Again in. Out and down. Breathe in as the arms up. Bring your hands to touch and lower the hands slowly down. That was the standing yoga. Now, I think it's Ironman Dry 3, where on the table of Iron of him there is seen a thing moving that has 3 things. Now, if it's one little one in the middle heavy one then, and then the third one. So if it's not a spiraling 2 but a 3 one. I thank you very much, and until next time.